An investment of $1,600 grows to $3,000 over 8 years. Find the annual interest rate if interest is compounded monthly. Okay, so let's start by identifying our variables. P, A, M, R, I, T, and N. Excuse me. Okay, so the initial investment was $1,600. So that is P, or the principal. Over the course of 8 years, that principal is going to grow to $3,000. So our accumulated value would be $3,000, and T is 8. And we need to find the annual interest rate, assuming that interest is compounded monthly. So our M would be 12. Over the course of 8 years, you have 96 months, or in other words, 8 times 12. So N is 96. We do not know anything about the interest rate. In fact, that's what we are being asked to solve for in this problem. So now we plug everything into the formula for compound interest. A is equal to 1,600 times 1 plus I raised to the 96th power. So to start, I'm going to divide both sides of this equation by 1,600. That leaves me with 1.875 equals 1 plus I raised to 96. Okay, so now I need to solve for I, which means I need to get it out from under this exponent of 96. So to solve this, I need to undo the 96th power, which basically means I need to take a 96th root. For example, let me just kind of scroll down for just a second to kind of explain how this is going to work, because it is a little bit tricky. Let's say I had something like, let me just make up something. Let's say I had something to the effect of, 16 equals 1 plus I squared. If I wanted to get rid of the squared, if I wanted to get rid of that 2, I could take the square root of both sides. Now, our calculators happen to have a square root button, but just for the sake of argument, let's say they didn't. Another way to calculate square roots is to raise something to the 1/2 power. We discussed before that raising something to the 1/2 power is effectively the same as taking the square root of it. So if I wanted to get rid of that squared, I could raise the right-hand side to the 1/2 power, which means I also have to raise the left-hand side to the 1/2 power. And so that would give me, on the right-hand side, the exponents here cancel. On the left-hand side, I could take the square root to get 4 equals 1 plus I. And then I would be 3 in that case. So, comparing to this example up above, if I want to get rid of that exponent of 96, I need to raise the right-hand side to the 1 over 96th power. And then to keep the equation balanced, I need to do the same thing to the left-hand side. Okay, so on the right, the exponents cancel. On the left, I'm calculating 1.875 raised to the 1 over 96. And that's going to give me 1.0065695. And so on the right, I just have 1 plus I. Now, real quickly, before I go further, I just want to point out, it's kind of tricky to enter this quantity into the calculator. So let me just show you over to the side exactly how you would type it into the calculator. You would type in 1.875, and then you'd hit the exponent button. And if you just write 1 over 96, that's not quite going to work out correctly. That's going to take 1.875, raise it to the power of 1, and then divide the result by 96. If you actually want the entire 1 over 96 in the exponent, you'll need to put parentheses. But if you enter it in like this, then you should get the correct answer, 1.065695. So the next step, I'm going to subtract 1 from both sides of this equation. And that's going to give me I equals 0.0065695. Okay, so we've now solved for I, the interest rate. But we're not quite done with this problem. If you go back and read it, we're asked to find the annual interest rate compounded monthly. So we actually want the annual rate, but I is going to be the monthly rate. So to get the annual rate, I need to take the monthly rate and multiply by 12. So doing that, I get the annual rate R to be 0.0788339. With all problems like this, I want the answer given as percent rounded to 2 decimal places. So that would be 7.88%.